All right, now let's do a checkpoint. So I'm going to read the problem, and then I want you to pause the video, work it out yourself, and then come back and see if you got the correct answer that I got. Okay? So, go ahead and pause now and come back. Okay, or excuse me, I'm sorry. Let me read the problem first, then pause. Okay, so here's the setup. It says, write an equation for the simple harmonic motion given d is equal to 0 when t is equal to 0. The amplitude is 6 centimeters and the period is 3 seconds. Then find the frequency. So that's where we're going to start. So go ahead and write all this down and then pause the video, work it out on your own, then come back and see if you got the same thing I got. All right, here we go. So what do we know? We know d is equal to 0 when t is equal to 0. And we know the amplitude is equal to 6 centimeters and the period is equal to 3 seconds. Okay? And that means the frequency is equal to 1/3 of a cycle per second, right? So, but they want us to show that. So we're going to use the definition of a frequency to show that. Okay? But let's figure out what our function is. So we got amplitude is 6 centimeters, right? Okay? So we know A is 6. Now we got to write the function. We're going to use sine before. Okay? Sine d is 0 when t is 0. Okay? So again, we're going to assume we're pulling the spring down, right? We could start by pushing the spring up, and so it'll be traveling downward in the negative direction, right? And so that would change whether A was negative, start out negative or not. Remember that, okay? But let's assume we're stretching the spring down in the negative direction, and it's traveling up into the positive direction, okay? So we're going to use sine too. So d equals 6 sine of omega t. And of course, we got to figure out what omega is. Remember, the period is equal to what? 2 pi over omega, which then implies that what? Omega is equal to 2 pi over the period, which is 3. And so omega is going to be 2 pi over 3. We can't simplify that anymore. Okay? So now, what do? Well, we're going to plug in omega. And so our final answer becomes what? 2 pi over 3 times t. And so this is our function that models the harmonic motion of this particular example. Now, let's verify what the frequency is. Okay, we already know what the frequency is, but if it asks you to verify it, that's just basically we have to prove it. So now what we're going to do is we're going to say, okay, well, this is by definition omega over 2 pi. And omega we know is 2 pi over 3, so we're going to plug that in. So 2 pi over 3 divided by 2 pi, which again we can change this. This is equal to what? 2 pi over 3 times 1 over 2 pi. And of course, look at that. We can cancel the two pi's, and that equals 1/3, which is exactly what we knew it was going to be. And so that is the answer. All right. If you didn't get the same answer, reach out to me or make sure you check your work and see where you made your mistake. Talk to you later. Bye.